Greetings to you all. My name is Kinile Mulap, and today I'm going to teach you fitting and turning systems and control system drivers for in mechanical technology grade 10. So we'll start by drive systems, spare gear, pulleys and belt drivers, chain drivers. So firstly, before going to do more things, I think you have to know what a spare gear is. A spare gear, it is the most common type of gear. It consists of cylindrical wheel with teeth that cut parallel to the axis of rotation. These gears are used to transmit motion and power between parallel shafts. So you have to know that uh, this this are your teeth. Ne? So they say a spare gear, it consists of a cylindrical wheel with, this is your wheel again, with the cut, with the straight teeth are this one. So again, that cut parallel to the axis of the rotation. That cut parallel to the axis of, it rotates here. So this one goes this side and this one goes this side. So the other thing that you have to know about gears. Let me give you an example. So you have a watch. Like gears also apply on the watch. There is work when they are there in the watches. So you have a watch, your watch. So nowadays, we have smartwatches which you just plug your charges and whatnot. So you have a watch. Having a watch there, your watch always it is working what? It is working well. So you never imagined that. I guess there are some watches that you don't charge them. Only maybe the battery can be finished, then you replace it with another battery. It works maybe for 2 years. So now that watch, or that watch to work, like to work properly, it has a spare gear inside. Okay? So those spare gears they are applied in that watch. So here, those big gears in the watch, again, they are used to do what? To transmit motion and power between what? Between parallel shifts. So that's why your watch is working well. It has that spare gear inside. That spare gear, it is used to do what? To transmit motion and power between parallel shifts. So now we are coming to a pulley and belt drive. So a pulley and belt drive is a mechanical system used to do what? To transmit power and motion between rotating shafts using wheels and flexible belt. So this one, it uses what? It uses wheels. It uses wheels and what? And flexible belts. So let me give you an example. An example will be maybe your fan, or let me say your washing machine. So your washing machine, you plug that machine, you plug the machine there, then the machine works. How does that machine manufacture? How does it work? How is the uh, a pulley and belt drive applied there? So when you plug that machine again, it transmits what? The power transmitted and the motion between rotating shafts. That power is transmitted using what? Using wheels and flexible uh, belt. That power it is transmitted. It is transmitted so that the machine can work properly and wash your clothes. That power transmitted, it is transmitted using the wheels and the what? And the flexible belts. So you have to know that we have open belt drive and the closed belt drive. So the difference here is that the open belt drive, when the open belt drive, the police, like the driven police, move in the same direction. They do what? They move in the same direction. Then for a closed belt drive, the driven police here, or the wheels, they move in opposite directions. They don't move in the same directions. So you must also know that if maybe this wheel rotates or it moves, it will cause the belt to also move. So when the this wheel is moving and the belt is moving, what happens? Also, this other belt, this not belt, also this other wheel will also do what? Will also move. So now let's come to chain drives. Chain drives is a power transmission system that uses a chain and toothed wheels to transfer motion and force between two shifts. This one, I can give you an example with a bicycle. Like you can see how you ride your bicycles, how you go with your bicycles. So you have to know, like your bicycle has a chain, has this chain. Your bicycle has this chain. Then it has this wheel. So it has this. So this wheel has what? Has this tooth. So this chain, it goes like you can see here. Actually, this is your tooth here. Then me, this is your tooth here. When this wheel rotates, when it maybe it goes like this, ne? Also it go the what the chain will go in the motion of the what of this air wheel. So you have to know that a chain drives is a power transmission system that uses chain and tooth wheels to transfer what motion and force between the shafts. This transfer motion and force, a force is transferred there. There is a force. Like you are driving your bicycle. When using those wheels, you are transferring a force. You use your legs. Second. So you're transferring a force and a motion between two shafts. So your bicycle do what? It goes. So now let's come here. Uh, the other thing you have to know, I get this is your spare gear, your pulley and belt, your chain gear. So you have to know the advantages and disadvantages. Advantages of a spare gear is that the spare gear does what is efficient. It is what? Efficient. Disadvantage is that no sleep. So it is what? Noisy. King parallel shifts only. It has what? Parallel. It has what? Pa, pa. Parallel shifts what? Only. Noisy parallel shifts only. So these parallel shifts are what? Are noise. They are noise. So for this one, advantages it is quiet. Ne? It can sleep. Disadvantage is that it can sleep. Then wear over time. Then advantages here, no sleep, handles heavy load. So this one, it handles what? Heavy loads. That's an advantage because it can what? Can handle heavy loads. But the disadvantage is that it is noisy, requires a lubrication. It is what? It is noise. So now, before I come to this, and let's start with gears. Okay, for gears, let me say gears. So you have to know the formula for gears. I got the formula for gears is N1 T1 is equals to N2 T2. So here you have to know that like you don't just know the formula. You have to know what your N stands for. Your N stands for what? Speed driven by the gear. Your N here stands for the speed driven by the gear. Then your T stands for the tooth or the number of teeth. Then let's come to police. The formula for this is N1 D 1, which is equals to what? N2 D2. So here you have to know what your N stands for. Your N stands for the speed driven by the pole. The what? The speed driven by the what? By the pole. The what? The speed driven by the pole. Then your D stands for the what? The diameter driven by the pole. Again, your N stands for the speed driven by the pole. Your D stands for the diameter driven by the pole. So now let's come to the formula for belts. Belts, okay. Belts. So this side will say your belts is V equals to what? Pi. Pi what? Your pi. Pi dn. dn. You have to know what your your interest stands for. Your V stands for belt speed. Your belt speed, which is measured in millimeters per minute. Then your pi is there on the calculator. Your D stands for the diameter of the the diameter of the pole, which is in millimeters. Then your N stands for the rotation in speed, in RPM. So now let me check my calculator so that we can start with the bargain, with these questions that I have for you. I think you have now understood the formulas. Okay. Now, let's start with the first one. Okay. The first one, it says a driver. The first one, it says a driver. It says a drive system, not driver. Sorry, guys. A drive, let me make this font. It says a drive system gear with 20 teeth. So you have your T1. T1, you chose to. You have to write them so that you can never forget, which is equals to 20. Yeah, yeah. Rotates at 300 RMP. So you have your what? Your N. Your N1, which is equals to what? 300. Then 300 and driven drive a gear with 40 teeth. So that means you also have your T2. You have to write these things so that you can never forget. Your T2 equals to what? Equals to 40. Yeah. Your T2 equals to 40. But calculate the speed of the driven gear. Again, I told you what N is. So now we will say N1 times T1 is equals to, this formula is for what? Gears. N2 multiplied by T2. So you have your N1, which is 300, multiplied by, you have your T1, which is your 20, which is equals to, you don't have your N2. You're looking for what? For your N2. N2. Your T2 is how much? Is 40. So here you'll put multiply by 40. So what is, okay, 300 multiplied by 20, which is how much? 6,000. 6, 2, 3, 6,000, which is equals to 40 and 2. So to get your N2, you have to do what? You have to divide both sides by what? By 40. By 40, this side, then divide by 40. Then your N2 is equals to, so you'll say 6,000 divided by 40. So your answer is 150. 150. Remember your N is your SI units for N is RPM. R what? RPM. So you're done with the first one. Let's go to the second one. Let me erase this for you so that we can write the second one. So the second one, it says, let me use a thinner one, okay. The second one says, a driving pulley with a diameter of 100. So you have your D1, 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 which is equals to what? 100. Then rotates at what? At 5, then you have your what? Your N1. Your N1, which is equals to what? Which is equals to 500. Then, Barry, it drives a second pulley with 200. You have your D2. Drive a second what with how much? With 200. Your D2 is 2 equals to what? 200. So calculate the speed of the driven pull. The speed. So it will be N1 D1 N1 multiplied by D1 is equals to N2 multiplied by D2. Hey, so your N1 is what? 500. 500 multiplied by what? Your D1 is 100 by 100, which is equals to your N2. You don't have your N2. You have your D2, which is what? Which is your D2 give away 200. So now you have to say 500. You have to say 500 times 100 times 100, which is equals to 5,000. So this side, your answer, this side is 5,000, 5,000, which is equals to what? 200, 200 and so N2. So to get your N2, you have to divide both sides by what? By 200. Divided by 200, 200, divided by 200. So you will say 5,000. So, okay, 500 divided by 2,000. So your N2, let me do it like this. Your N2, guys, please, please, please use your calculators, because if you use your head, you'll make a mistake. Your N2 equals to 25. M. Okay, now let's go to number 3. Okay. For your number 3, they say a poly with a diameter of 100 and so you know your diameter now, yeah? But a poly with a let's repeat the second one. I think I made a mistake. It's okay, 500 times 100, which is 50,000. Sorry, guys, that's not 5,000, it's 50,000. Then you take that 51, 2, 3, 50,000, you divide it by 200. So your answer, it's going to be 250 RPM. Sorry for my mistake. So, number 3. Okay, let's do number 2 again. Now, it's going to be 100. 100. You multiply it by 500, which is going to be 5,000. Then you divide it by what is on your left hand side. So now, barring. Now we are coming to this one. A diameter of okay, diameter, they give us the diameter TD. Diameter equals to what? Equals to 100 and what? 150. Okay, so after giving us the diameter, it rotates at what? So they give us our n. Our n is how much? Is 300. Yo, sorry. Sorry, bana baka. Your n is what? Your n equals to 300, equals to 300. So they say we must calculate the speed. So I told you about this formula that our speed is what? Is the V is the belt speed. So our formula will be V equals to pi dn. Pi dn. And don't forget that the speed is the V. So our V is equals to, I get a pi is on the calculator, f pi, your D is how much? 150. Then your N is 300. Please, guys, use your calculator. So we will round off this to the 2 decimal places. So your V will be equal to, okay, we'll be doing this to what? To 2 decimal what? Places. So your V will be equal to, let me see, okay, pi multiply by 150 multiply by 300, which is equals to 1, which is equals to 1. So there's second, which is equals to, okay, 1 4 1 3 7 1 comma, we are going to round off to what? To decimal places. 6 7. So our answer here is going to, it's not they say our answer must be in what? Must be in meters, not what? Not millimeters. It must be in what? In meters, not what? Not millimeters. So our answer here is millimeters per minute. Millimeters per minute. Okay. So that means our total answer will be uh, V equals to, we are going to do what? We are going to divide this by what? By 1,000, from millimeters to 14 1 371,67 divided by 1000. So your answer is going to be 14,37. Oh, did I get we are rounding to decimal? 14,37. They want it in what? Meters per minute. So it will be in your answer will be in me. So if you have to read the statements or at the statement they say what? If they say if they say just calculate then you know that it is in what? Millimeters per minute. So here it's going to be meters per what? Per second. Then that's your final answer. So now you have to know the thread types, which is the ISO thread, the ISO thread, yeah, the metric thread, the V thread, fine thread, cos thread, square thread, and azimuth thread. So you have to know that the IS thread profile is V and the angle is 60 degrees. The property is what is global standard. Then common uses are bolts and nuts. So the metric thread is V. The profile is V. The angle is 60 degrees. Property is fine, like fine. Then common use are tools for metric. Then the profile is V. The profile is V, the angle is 60. It is a centering, I mean, it is a self-centering. So, general fastening. So, the fine thread is V, the profile is V, the angle is 60. The property is tight fit. Precious parts, common use are precious parts. Then the cos thread profile is V, angle is 60, fast assembly. Then common uses are wood. Then the square thread profile is square, angle is 0. Properties high efficient. Then common use are lead screws. Then the azimuth thread is V. Like profile is V, angle is 60 inch based use machinery. So now you have to know that all of these threads has the angle of 60, but only the square thread has the 0 uh, angle. That's what you have to know. That's what is very important. You have to know that. So now I want to maybe give you an image so that you can see. Instead of using an image, let me maybe show you the ISO thread type. The ISO metric. It is like this. You'll be drawing your like this. So for my lens going straight and like this. I so let me use another color here. So okay. So maybe let me shade here, like here. Let me shade here, let me shade here, let me shade here. So here it's your maybe that land. So now this angle here, it's what? It's at 60. At 60 what? At 60 degrees. At 60 degrees, this angle here. So now let's go to a V thread. A V thread, it's also like this, like. Like they are the same. If V thread is also like this one, I just do like this. That's your V thread. Then maybe, okay, this is your symmetrical line. They just do it like this. Then here, in between, it's your angle, right? It's your angle this side. This angle is sixth, sixth, sixth. This angle is sixth. So you also have your, so the difference here is for the square thread. So let me show you the square thread. The square thread. It is like this, ne? It is like this. This is your square. This is your square. Then like this, like this, like this, like this, like this. So this is your line, symmetrical line here. So the angle here is 0 degrees. I hope you understand. Like your angle here is 0 degrees for your okay, for your square thread. That's the examples that I can show you. So the ACM and the square thread, they don't have 60. This one has 29. So let me also draw an example of an ACM. Okay, ACM thread. Okay, let me draw it this side. Okay. The one that has 60 is not ACM, is the ASME. So ACM, it's like, okay, hammer, I can draw it. It's like this, then like this, then it turns like this, then it's like this, then it is like this. Yo, okay, let me draw it again. So your ACM, ACME is like this, then like this again. Then like this, then you turn like this, it's like this, then like this. So your angle here is 29. Like your angle here, it's what? This is your two symmetrical line. Then your angle here is what? Is 29. It's 29. So these questions you have to maybe know. Let me repeat the things that I said about it. Okay. These ones, their angles are what? Their angles are 60. Then for the square is what is, you have to know the common uses of these threads. Again, the common use of the first thread is bolts or nuts. For the second thread is tools. Again, for the third thread is general fastening. Then for the fourth thread is precious parts. Then the other one is wood, the other one is lead screw and USA machinery. So, since in the beginning I told you the properties, the profile, the angle, and the common use, that means you can answer a multiple choice question. This is sort of theory. Okay. Thank you guys for today's lesson. I we will meet again with another topic.